Hey, this is Joel. Welcome to another Visual Basic Tips and Tricks. There's going to be two of them today. First will be Intermediate Language, or IL, and the other will be you can actually use pointers in Visual Basic Net. We'll get to that in a minute. So first, on to the IL. There are lots of websites which have information, but a lot of them include what for me was bloat. I just wanted the bare minimum. How do you make a sub or a function using intermediate language? And this will be a good springboard for the basics, and you can dig deeper from here if you're interested. So, as I'm sure you know, intermediate language ought to be simplistic. It's one step above machine code. In fact, writing programs with it is like writing in a simpler language. I'll show you down in a minute. First thing you want to do is put it in a module instead of a class. The difference between a module and a class mainly is when you include a module in other classes, you just use the sub or function name. You don't have to do an instance of it. So there's nothing, dot name of sub or function name. Like for memory copy, it's not used in here, but if it was used in here, it would just be memcopy. Nothing else. You wouldn't have to do something equals, like the module name is native, so you wouldn't have to do, n equals native and then n dot memcopy. You include the native module and then directly use the sub or function names, just in case you didn't know. So next, you want two imports, system.reflection.emit and system.runtime.interop-services. All right. Now it's funny, even though you don't use this anew like you would in a class, you put all the body of your subs and functions, all of them go inside sub new. Why? Because, for instance, we use a bunch of subs and functions in here, but there isn't native.new or anything like that. We don't type it in. It just works. I don't know why we put it there, but that's just how it works, and it works. So first thing you want to do is, for sub or function, you put public delegate and then sub or function, and then the name of your sub or function with capital F, func, short for function, appended to the name. So for here, memcopy is memcopy func, parentheses, put in your arguments, or none if you don't have any. Then underneath, public read-only, the actual name without the func appended as the name with the func appended. So you can see here, memcopy as memcopy func, write32 as write32 func, and so on. So say there's some subs and functions. We don't actually use memcopy. There's actually valid uses for it, but it's not used in this program. Rank 2, it's shown how it works. There's a thing that shows how it works, so we'll go over it then, but there's really no point to it. I just did to test it out, see if I could. Although I will actually go there because it has some stuff you can use in case you're not that familiar with IL. By the way, if you want to know what IL opcodes there are, they're called, basically because it's like assembler, they're called opcodes. You can Google vb.net opcodes class, and it'll give you all the opcodes that you can use, IL opcodes you can use. So anyway, and then idiv round. I wanted to see if using intermediate language, I could do a routine where you do a integer round, divide, which of course there's no point anything. But if it was 0.5 or above, then add a 1 to the result. So I did that using IL, and then I tested it against using regular Visual Basic, which you'll see in a few minutes. And actually, what's built into Visual Basic is much faster. So, because I've always heard that usually the code optimizers will come out with anything faster than you can think of, and for the most part, it's true. Okay, so I got how you name your subs or functions. So let's go into sub new, which will have the code for it. So the first one, they'll do memcopy. Okay, you get a variable as a new dynamic method. In this one, for most of them, it's a shortening of dynamic method, dyn mtd. Like here's that, then dyn mtd2, although it's not for all of it. Like here's w64 for write64, but it doesn't matter, just as long as, well, you'll see, you stick to the same name in the sub or function that you're doing. So for here, it's dyn mtd as new dynamic method, parentheses, in quotation marks, the name of your sub or function, okay, comma, get type, and it's going to be the return type, which, because this is a sub, the return type is void, comma, curly brackets, and inside the curly brackets, you get the type for the arguments that you're going to be passing along. So as you can see up here, its destination is int pointer, source is int pointer, byte length as unsigned integer. So go back here, dynamic method, and the curly brackets get int pointer, unsigned, get unsigned integer. Then after curly brackets, comma, get type, and the name of the module, which in this case is native, excuse me. Okay. Then you dim a variable as an IL generator, which of course here I just IL gen, and then you make that equal to the dynamic method variable dot get IL generator. Then you can do the code or the opcodes. So IL gen, in this case, dot emit, and then in parentheses opcodes dot and whatever opcodes you need. So as you can see with the remarks here, load arg0, which is the first argument, load arg1, the second, load arg2, the third, then copy block, or it's a block copy. It'll use the number that's in here, the third argument, to transfer bytes from the source to the destination. And for all subs and functions, do an opcodes dot return. After the return, you put the name of your sub or function equals ctype, parentheses, the dynamic method dot create delegate, parentheses, get type, the name of your function with func appended, and then comma, the name of your function with func appended again. So that's the basic of how to create. Now, like I said, this is a sub, so the very first get type is void. However, if you have a function, like let's go down here, okay, read 16. It reads 16 bits from a offset, a memory offset. So the very first get type will now be int 16. Okay, read 32, it returns 32, so you get type int 32. All right, now you can use, here, let me get down to rank 2, yeah, there we go. Okay, you can use labels. So here, later there'll just be a program that program. Anyway, you'll see how it works. Pretty simple. You put in two numbers. If the first number is bigger, it returns 1. The second number is bigger, it returns a 2. If they're equal, it returns a 0. So, like here, okay. You load arg1 and arg0. This one is branch if the second argument is bigger than the first. And you go to the label v2 gt, which is great, which means greater than v2 is greater than v1. How do you do a label? Well, you do the variable for emit, but instead of emit, you do mark label, and then you do the label name. So, like here, v2 is greater than v1. Here's v2 is greater than v1. You'll load the number 2 and return. Here you load the 2 again, and if the first is bigger, then you go down here. No. If it's equal, I'm sorry, you go here, load a 0 and return. Otherwise, load a 1 and return. So anyway, this is how you make labels, and then you can use branch to the labels. And no matter what, after anything that you're done doing, you return. And then, of course, you do the name equals ctype, the variable for dynamic method, create delegate, and then you get type, the name with func, and then again name with function or func appended to it. Okay, so that's pretty simple. You can Google more if you want to get more into it. Maybe you already know all this stuff. In which case, I guess you don't need to Google anything. All right. Now, memory copy isn't used. Some writes and reads are used for the variable pointers. And also, okay, besides variables, there is, here, I'll get down, here we go, a test pointer and a string reference. You know, if you do something by ref instead of by value, you pass the reference. Well, this returns the reference only. Here, let me scroll down. So for instance, test pointer, instead of getting the offset, you're getting the reference location. But that seems to work the same as offset, and I'll show you in just a minute. So for here, like, okay, you put in, this will give you the reference of an int32. So you get int32, but then you put dot make by ref type. So this is passing the reference instead of instead of what's inside the variable, you're getting the reference to the variable. You load the reference, and then you return, which returns the reference. The same goes for the string here. You put a string in, you put the string reference. So instead of, you know, like the first letter or character, excuse me, that's in the string, you'll get the string reference, load it, return. This returns the string reference. Okay. So the string and variable references are like a safe form, I think, of the pointers. Now, you can use variable pointers in netcode. This is from VBNet 2019, but I'm pretty sure it'll work in 2022. You just have to get it out of a DLL. And so what you do is you declare function, you put the name, library, and then the DLL you're getting it from, alias, and then that seeds var pointer, alias var pointer, parentheses, any arguments. Now these are all the same except for the argument. That's, you know, it's like a override. They'll all return N64s, which is the 64-bit offset. And I'm just doing the signed. You could make this twice as big and have a byte, and unsigned N16 and unsigned N32 and unsigned N64. Now this seems to work if you use a string. There was a string pointer, but I think I couldn't get it to work right. But if you use a var pointer to a string, that seems to work just fine. And I'll show you in a second. So let's go to here. Okay, we're going to run it. Now, we'll just get the integer divide round out of the way first. So we do this 10,000 times, and I use a stopwatch. So just 5 integer divided by 3 10,000 times. This has all the way to 274. There's 3 digits here. Now, the way to use Visual Basic is you do 5 divided by 3. I have a variable quotient which gives the answer. Then, if 5 mod 3 times 10 and then divided again by 3, divided by the dividend. Oh, that's just supposed to be an equal there. I forgot to put that. But equal or greater to 5, then you add a 1, which case it is. It's like 6. So now you have 2. And done 10,000 times, it doesn't add very much. It adds, anyway, you see here, it's less than 400. 3 something. Now, mine, which uses intermediate language, gives you a 2 like above, but I did I forgot to put it here, but it's like 36, 37 times slower. So, yeah, when they say that the Visual Basic or C or whatever, code optimizes, the compiler optimizes, it really does. So now we're going to do, for the test variable pointers, now we have variable A, which is an integer, B and C are strings, and they're class-wide variables. Sub A is an integer that's only inside the sub. So you can get the variable address and hex from the var pointer, sub with var pointer, and then test pointer for variable A. As you can see, it's actually, I call it a pointer, but it's actually a reference, or by reference. So that's completely different. However, using them will both get you the same, they'll both point to A. So, for example, here's variable A is 3. If you read the test pointer, which is, I gotta pause the video 1 second. Okay, I had to pause and take care of something. So where was I? I think I was reading variable A equals 3. If you read the test pointer, which is actually the test reference, whatever, it'll give you 3. So this proves that the reference is pointing to the variable A. Now, we use write 16 to write 80 inside of A. Then we're going to show variable A equals, I wrote this, I need to redo this. So variable A it's just showing variable A to string, and then slash, and then read 32, the var pointer of variable A. Also read 32, test pointer. Anyway, it shows that when you set it to 80, variable A is 80, reading from var pointer, which is, of course, I'm sorry, that is actually a variable pointer, will give you 80, and reading the test pointer, which is the reference, will give you 80. So, so the reference and the variable pointers both point to the same thing and give you the same results. Rank 2, I already talked about it. This just shows how it should work, and it does work, so I haven't used it for anything. Okay, so variable B is ABC. Now something I forgot to look into. I'll have to see why, but so if you read car, it returns a character. So in this case, it'll be the var pointer of variable B, and then read 16 bits from variable B. Anyway, so the character is A, which is the very first one, of course, and the read 16, maybe I should just make it a read 8, because it gives you 41, 42, which I think is AB, but then if you increase the offset by 1, you get a B, which you're supposed to get, but read 16 gives you BB instead of BC. So I'm not sure if there's something wrong with that. It shouldn't be anything wrong, but it doesn't give you what you'd expect. Now, write 64, and this is the string pointer. You know what? I gotta check something here. Variable B, and you write over it with a string pointer to variable C. 64 bits. Okay, I think I know what happened. Anyway, so it seems to work at first. You go back, and instead of the first letter being an A, it is now an E, and the other one's an F. But if you try to run this twice in a row, when you get down to here, okay, it gives you a problem. I'm going to stop. Saying there's a null pointer, and I think that's, okay, str reference, wait a minute. Oh, string reference, yeah. Anyway, using that, it works once, but if you use it twice in a row, it'll give you a null pointer when you try to read from it for some from the string for some reason. So I think, yeah, string reference must be from here, I think, right? Yeah. Yeah. So that's the only one that gave a problem when you run it twice in a row. So I guess if you wanted to run it twice in a row and have it work right, instead of using string reference, you'd use var pointer. Okay, I'm guessing when you redo it, the reference must change, but I didn't get the change. That's weird. Anyway, all right. Anyway, I think I figured it out. This is just a light jumping point. You can do Googling and stuff, experiments to get even deeper if you're curious of either intermediate language or getting pointers. So I'm going to stop this for now. Thanks for watching, and take it easy.